Hey there, Seahawks. It's Miss Adams, and in this video, we're going to learn how to estimate a proportion. All right, how to check the conditions for constructing a confidence interval for P, a population proportion. So, random, the data come from a random sample from the population of interest, and large count, so both n times p hat and n times 1 minus p hat have to be at least 10. All right, so let's practice checking these conditions. A random sample of students who completed the census at school survey was selected. Of the 227 in the sample, 84 reported they had allergies. We would like to estimate the true proportion of students with allergies in the population of the school who took a census at school survey. Check if the conditions for calculating a confidence interval for P are met. All right, so it needs to be random. It was stated, so the 227 students in the sample were randomly selected. And large counts, n, my sample size, 84, or 227, times p hat, my proportion, my sample proportion was 84 out of 227. So n times p hat gives me 84, which is greater than or equal to 10. And n times 1 minus p hat gives me 143, which is also greater than or equal to 10. So our conditions are met. All right, the critical value. The critical value is the multiplier that makes the interval wide enough to have the stated capture rate. All right, so if we're doing 95% or 90%, it gives us that value so that we can make sure that it's going to be wide enough for that level of confidence interval. Critical values are noted by a star or sometimes a subscript of a C, so Z star or ZC. Standard error of p hat. The standard error of p hat as an estimate for the standard deviation of the sampling distribution of p hat. So we don't know p, so we use p hat. So we're not finding the standard deviation, we're finding the standard error because we're not plugging p in. Is the square root of p hat times 1 minus p hat over n. How to calculate a confidence interval for p. So first, we're going to check to make sure that the random and the large counts conditions are met. And then we're going to do our point estimate plus or minus our margin of error. Our point estimate would be p hat, our sample proportion, plus or minus our margin of error is made up of z star, which is the critical value, times the standard error of our statistic, the square root of p hat times 1 minus p hat over n. All right, finding the critical value. So we could use table A, which is the Z table, or we could use technology. I'm going to kind of go over both for a 99% confidence interval. Assume the conditions are met. So if I have this normal curve, the Z-scores come from normal distribution. So I have a normal curve, and I have 99% taking up the center area. Well, that would leave me with 1% left over, and that's split up between the two tails. So each area would be half of a percent. 0 is going to be my center. And I'm trying to figure out the z-scores, how many standard deviations I am away, so that 99% is in the center. So when I calculate this, when I look at my table, I would look for in the center, the area of closest to 99%. And so you have to kind of find it in the middle of all of the table, and then go up and over to find that z-score. So it's 2.58, and so this would be negative 2.58 and positive 2.58. Using technology, I could do inverse norm, and then the area, I'd put the area on that little left tail, 0.05, mean of 0, standard deviation of 1. If you have an updated calculator, you could also put the area of 0.99, mean of 0, standard deviation of 1, and then pick center. And you get negative 2.576 and positive 2.576. And when we're doing Z star critical value, it's always the absolute value. It's always the positive version. All right. Calculating a confidence interval for P, a random sample of students who completed the census at school. So this is that same question from the problem 1. Calculate a 95% confidence interval for P, the proportion of all students who completed the census at school survey who have allergies. So calculate P hat. P hat is 84 out of 227, which works out to be 0.370. Make sure the conditions are met. Well, random was stated, and large counts we checked in example 1. Find the critical value. So I need to find Z star for 95%. So inverse norm, if I'm using the calculator with the left, right, center, I'd put area as 0.95, mean 0, standard deviation 1, center. I get Z star as 1.960. And then compute the confidence interval using the formula P hat plus or minus Z star times the square root of P hat times 1 minus P hat over N. So P hat was 0.307 plus or minus Z star was 1.960. The square root P hat 1 minus P hat over N. Calculate those. Because I have a plus or a minus, I have to do this 2 separate times. I have to do it with the minus first and then the plus to get the lower and the upper values. In your calculator, you can also calculate the interval. So you would press stat test. We're working with one proportion. So one sample, and we're working with proportion. So this is a one proportion Z interval.